All right, so take a look at numbers 1 and 2, and then I'm going to talk about them. I am going to walk around and check for completion while you're checking for accuracy on numbers 1 and 2. This was your homework. This is the first review sheet that was front and back.
Oh, I did that.
I just typed out my answer keys with graphs to make it prettier. Okay, awesome.
I'm accurate. I don't even know how. Days my back. My back.
Okay, you guys should be checking 1 and 2.
I mean, just get my accuracy. Review. Yeah, what are you trying to do?
Yeah, I'm not being funny. I didn't remember one. Yeah.
You guys should grab me, guys. Oh my God, guys.
Numbers 1 and 2. You can see all of 1 and 2 on the overhead right now. Okay, so as we look at number 1, number 1 said, graph the transformation of the parent graph of the square root of x function above. Then give the following: the domain, the range, the intercepts, the extrema, the intervals of increase or decrease, and the end behavior of the function. And so what they ask us, the transformation they asked us to graph was this one. Y equals the square root of x plus 3. So what did that do to our square root function? Shifted it up 3 units. Did not change the domain, because we didn't shift it right or left any. So the domain is all the values from 0 to infinity. So we include 0. Make sure you use, now remember, domain and range is where I'm very picky about, is it a bracket or is it a parenthesis? A brace. All right, and then the range, because I shifted the entire function up 3 units, the range is from 3 to infinity. There are no zeros or x-intercepts, are there? When I shifted it up, it doesn't touch the x-axis at all. So there are no zeros or x-intercepts. We do have a y-intercept at the point 0, 3. This problem does not have an absolute max because it continues forever. But it does have an absolute min, and the minimum value occurs when the function has a value of 3. You could put it occurs at the point 0, 3. This function is increasing from the x values of 0 to infinity. So remember, we use our x values when we talk about increasing and decreasing intervals. So it increases from 0 to infinity. And we are not describing this end because it does not continue, but we can describe the other end. As x approaches positive infinity, the function also approaches positive infinity. Any questions about number 1? All right, let's take a look at number 2. Your direction said, give the intervals where the function to the right is increasing, decreasing, remains constant. State the zeros and the intercepts of the function. Find the average rate of change from x equals -5 to x equals -2 over the interval from 0 to 3 and from x equals 3 to x equals 7. So this is the exact graph. Oh no. Moby died.
Moby.
Are you
Moby.
What is it filming?
It is filming. It's filming. Yeah, it's still recording.
Miss Wolby, is this
Yes.
going on YouTube?
I'll post it to my YouTube.
YouTube, baby.
Okay. Alright, so I plugged the Moby back in, so we're working. Alright, so this is the exact graph. It is increasing from 3 to infinity. Remember, we describe the increasing, decreasing with the x values. And when we did this in class, didn't we draw the x-axis down here? And we said, okay, this is negative infinity, this is positive infinity. Let's put those points where things change on here. They change here at -2. They change here at +3. What is this function doing from negative infinity to -2? Well, my finger goes down, so this is a decreasing interval. What happens from -2 to 3? It remains constant. And then from 3 to infinity, it is increasing. So how would I write that? Increasing is from 3 to infinity. Decreasing is from negative infinity to -2. And it has a constant interval from -2 to 3. Okay, the next thing it asks us for, it asks for the zeros of the function. This function has a value of 0 when x is -7 and when x is +5. The function has a value of 0. So my zeros are -7 and 5. My x-intercepts are at the same spots, aren't they? -7, 0, and 5, 0. My y-intercept is the point 0, -3. Now, average rate of change. I showed you the points here, but you are given a graph. So you can just count it on the graph, don't you? You don't have to find the points and do the slope when you're given a graph. So the first one is the interval from -5 to, which is right here, to -2, which is here. Do you see I go down 1, 2, over 1, 2, 3. Down 2, over 3. So we could just count it, couldn't we? Okay, the next interval was from 0 to 3. So from 0, right here, is where the 2, 3, right here. Well, is there any rise? 0 divided by 3 is 0. And the last one is from 3, -3 to 7. Where's 7? Is it the top of the point?
Yes, ma'am.
Okay. So I would count. I'd go up 6 over 4. 6 over 4 reduces to 3 over 2. 3 halves. So you can do it by taking the points and plugging it into y2 minus y1 over x2 minus x1. Or, because you're given the graph, you can just count on the graph. Any questions about number 2? All right. Let's take a look at 3 and 4 now. Number 3 says state the domain, the range, and the end behavior of the function f of x equals 1 over x. So here I have sketched that graph instead of copying it, which I should have just copied it. I sketched it. Now, domain is all the values except for the asymptote. We talked about the asymptotes when we looked at these graphs to start with, and I'm going to sketch them in. There's an asymptote right here on that y-axis. There's an whoop, that's not what I meant to do. Interesting. Have you ever seen that happen before? There we go. There's an asymptote here on the x-axis. Okay, so if we go left to right, you see it does not have an x value right here. So the domain is from -infinity to 0, not including the 0. That's why we have the parentheses. Union with 0 to infinity. The range is -infinity to 0, union with 0 to infinity. It does not have an x value of 0. The graph does not have a y value of 0. Do you see why those are excluded from the domain and range? Okay, now in behavior, as x approaches negative infinity, let's look at this end of the graph. What is it getting closer and closer and closer to? The asymptote. Well, what is the y value at the asymptote? 0. And as we go to this end, what is your graph getting closer and closer and closer to? That same asymptote. So 0. So as x approaches negative infinity, y approaches 0. As x approaches positive infinity, y approaches 0. That's what's happening at the ends of that graph.
So that graph has two asymptotes?
It does. It has a horizontal and a vertical one. Okay. Let's take a look at number 4. You were given this graph on your review sheet. It says to give the domain, the range, the zeros, the intercepts, extrema, intervals of increase and decrease, and end behavior of the function. Well, this function continues forever left and forever right. Domain is negative infinity to positive infinity. Are we good? Range, bottom to top. Do you see that this point right here is the lowest value? So it goes from that y value of -4 up forever to positive infinity. Zeros. Where does it cross the x-axis? It's where the function has a value of 0. That's why we call it a 0. Well, the zeros occur when x equals -5 or -3 or 0 or 4. That's where our zeros occur, at x equals those values. Well, those are also my x-intercepts. So I would take all those and write them as an order. And my y-intercept is the point 0, 0. Any questions on domain, range, zeros, or intercepts? Okay, now let's slowly talk about the next one.
Relative.
Okay, that's what we're about to get to. Now let's talk about the extrema. All right, the extrema are our mountains and our valleys. We have a valley right here, we have a valley right here, and we have a mountain right there. Those are our extrema. So now let's talk about them individually. Looking at this y value of -2, is it the lowest point on the graph?
No.
Nope, so it would have to be a relative min. So a relative minimum value at -2, or you could give me the ordered pair at the point. Now let's look at this one. This is a mountaintop. This is a mountain. Is it the absolute highest point on the graph?
Yes, ma'am.
What does this do? What does that do? It is higher than the points around it, but because this goes up forever in either direction, it's not the highest point on the graph. There is no highest. It goes on forever. So this is a relative max, and the y value there is 4. And then this point, our valley, is the lowest point on the graph. So we have an absolute min that occurs where the function has a value of -4. Does that make sense for our extrema? All right, and then the last part, nope, it's not the last part. The next part is increasing, decreasing. Okay, so increasing, decreasing, we always go left to right. So let's do it like we did it at the beginning. You do not have to draw this. Whoops. You do not have to draw this on your test at all. Part of your test you can't even write on. Okay, so let's put those x values at those changing points on here. Okay, so we have at -4, I'm a little bit, this is, oh, I hate it when wow,
God.
bless you. That was amazing.
You know they just heard you.
Yeah.
That was amazing. Okay.
Yeah.
All right. So we have this one at -4. That probably looks a little closer. We have another one at -2, and then we have third one occurs at +2. Okay. So if we go left to right, do you see we're decreasing? Then we're increasing on this interval. Then we're decreasing on this interval. Then we're increasing on this interval. We use our x values. So it's increasing from -4 to -2, and then again from 2 to infinity. So we show that it's over both of these intervals by connecting them with the union. It's both of those. Decreasing from -infinity to -4, union with -2 to +2. And the last part is our end behavior. What is this end doing? What is this end doing? Well, as x approaches -infinity, y approaches +infinity. As x approaches +infinity, y approaches +infinity. Any questions about number 4? Okay, let's take a look at number 5 then. Now, does your number 5 have to look exactly like my number 5?
No.
Nope. It just says sketch a graph that has a minimum value at the point -2, 5, and it has a point of discontinuity at x equals 3. So yours does not have to look like mine at all. It didn't say anything about this has to be constant, does it?
No.
It just said this needs to be a min, so this point right here should be lower than the points around it. And there should be some type of discontinuity that occurs where x is 3. It could be jump, well, it says point, so it should be an open circle. Point discontinuity. Okay? Any questions about number 5?
Are we gonna have a question like that on our test?
It's possible. Yep. Okay, let's take a look at 6 and 7. 6, given the graph of x, f of x, create the graph of f of -x plus 2. So we need to shift it, we need to reflect it over the y-axis and shift it up 2. A negative here is a reflection over the y, and then this plus 2 is up 2. So reflect over the y, shift up 2. Take a look at your number 6, see if you have the same thing I have. If you don't, ask questions. Are we good?
Yes, ma'am.
Okay. Could you give the domain of this one?
Yes.
What is it?
-infinity to +infinity.
It's -infinity to 0.
Oh.
Domain is the x.
Oh,
Okay.
think that was
What about the range?
So, 2 to...
-infinity to 2. Good. Domain is -infinity to 0. Range is -infinity to 2. Excellent. Okay. Number 7. Transform the graph of g of x. Now this time the negative is out in front. That's a reflection over the x-axis. And then this -5 takes all my points and shifts them right 5. So the first thing I would do is reflect over the x, shift right 5. Take a look at number 7 and see if you have any questions.
Do you want the lines to be like the way they are?
Yours may not be perfect, but the dots, like the extrema, should be. It may not all be perfect. Okay, label the parent graphs. Your quadratic one, the y equals x squared, is even. The absolute value one, y equals absolute value of x, is even. Your inverse function, y equals 1 over x, is odd. The square root function has neither even nor odd symmetry. And the cubic function has odd symmetry. The parent graph does. Okay, any questions on labeling your parent graphs on number 8? So, how do we know it has even symmetry? It reflects over the y. How do we know it has odd symmetry? Rotational symmetry about the origin of 180 degrees. Very good. Okay, let's take a look at 9 and 10. Okay, so number 9 says, give the equation for the transformation of the parent graph of the absolute value function. Well, the absolute value function looks like this. It opens up this way. So this one's been reflected over the x. That's where the negative came from. It was shifted right 3. That's where the -3 came from. Remember, we have to do the opposite with our x. and down 2. That's where the minus 2 came from. So reflect over the x, right 3, down 2. Yes, sir?
Is it considered wrong if you put f of x equals negative f, and then absolute value x minus 3 minus 2? Like,
I'll come look at yours. I'm not quite sure what you're saying, but I'll come look at it.
If there's an F after the negative, would you
I think
count
that
off of that? Like negative with F?
down
Then
I got,
absolute.
I got it moved.
down to right.
Okay, I see what you're saying. If I give you this, then you would give me this.
That's what I did.
But if I give you this, then you would give me this. Do you see the difference?
Yeah.
And on this one, the parent graph was y equals the absolute value of x. So if I just gave you a function, yes, that's exactly what you'd give me.
So is it wrong if I'm in this function?
It is not correct. Don't ooh.
Well, he told me I was wrong.
Oh, all right. Okay, so on this one, the y's are doubled, so we're doubling our y's. So this is what makes the what? Whoops, that wasn't doubled.
This is happening right now.
Do you see how we double the y's? We shift left 3, down 4. So double your y's first. Left 3, down 4, new graph. Okay, y'all are really quiet, so I'm assuming that means we all get this. Move on. All right. Okay, now this one, explain in words what's happening. Describe the transformations. So, vertical stretch by a factor of 2. Shift left 4 units and down 5 units. Horizontal stretch by a factor of 2. Remember, if it affects the x, we always do the opposite. And we reflect over the y because the negative is inside with the x. A negative out in front is a reflection over the x. And shift up 1 unit. This is a vertical compression by a factor of a half. And shift right 3 units. Okay, number 12. How do we determine symmetry algebraically? A minute ago we did it graphically. Now let's do it algebraically. Okay, what's our rule? If we plug in negative x, I'm not showing negative x. Let's try it again. If we plug in negative x and we get out the original function, it is even. If we plug in negative x and we get out the opposite of every term, it is odd. If it's not this and it's not that, then it is neither. So in this first one, we plug in negative x. The first term switches to the opposite. The second term does not. It is neither. Plug in negative x. The first term switches to the opposite side. So does the second term. Odd. Last one, plug in negative x. Everything stays the same. Even. Okay, gentlemen. All right. Any other questions about number 12?
No, ma'am.
Okay, let's take a look at 13. We did average rate of change a minute ago on a graph. And we just counted, didn't we? Well, now we have to do average rate of change given a function. And there's another way. I could show it to you this way, I could show it to you this way, or I could do the inequality, couldn't I? Could give you any of these 3 versions. So, I am only giving you the x values. Well, that's not enough. Because the average rate of change is the difference in the value of the function, which is our y values, over the difference in the value of the x's. How do I find the y values if I'm only giving you the x values, Brian?
You plug them in for the x.
You do. So if I take the 0 and plug it into this function, I get out 4. If I take the 1 and I plug it into this function, I get out 8. Now, yesterday I had several people in each class go, well, shouldn't this be 25? Because when I plug in 1 and I square it, but if we look at this first term, this really means 5 times x squared. So we have to square the number first before we multiply it times 5. Okay? All right, and when we do, then we do y2 minus y1 over x2 minus x1, and we get 4. And then for part B, we get 14. Take a look at your number 13 and see if you have any questions about parts A or B.
I aced it.
You aced it? Okay. Are you feeling confident? Okay. Have you, as we've gone over this, noticed areas where maybe this I need to look over tonight? Okay. Good. That's what you should be looking for as we go through this. All right. Let's look at that last sheet now. Okay. So here's a little graph. And is this graph a function? Well, it is. It passes the vertical line test, doesn't it? Now, this point right here is actually not a point, is it? It's an open circle. If it's an open circle, that means that this curve comes right up to it, but never quite gets there. If it were a closed circle, would it be a function? No, because then it would fail the vertical line. So we're good. Okay, now this, evaluating functions. We did this in the first unit, didn't we? I bet we see this on the benchmark. I bet we see this on the end of course test. What is the value of the function when we plug in -4? When x is -4. Well, when x is -4, the value of the function is -1. What is the value of the function when x is -2? When x is -2, the value of the function is -3. What is the value of the function when x is 0? When x is 0, the function has a value of 1. What is the value of the function when x is 2? Oh, it's not. It's an open circle, so I got to go up here. When x is 2, the value of the function is 1. Any questions about number 2? All right, number 3. Find x where the function has a value. So when the y is 2, so let's come over here. When the y is 2, right here, what is the value of the function? 3. Okay? I'm going to use the line drawer next time because I did a terrible job. All right. When the function has a value of -3, that's better, is it? All right. Try one more time. What is the x value? Well, this one's an open circle, so does it count? No. So what is the x value here? -2. Okay. When the function has a value of -4, does the function ever have a value of -4?
No.
No. It does not exist. It doesn't happen anywhere. All right, give the domain and the range. The domain is from -infinity to +5, and it includes all those values. Because this one x value that had the open circle here, we actually ain't there. The range is from -3 to +3 because it includes all y values from -3 to +3. Any questions about domain and range? Number 5, what are the zeros, x-intercepts of the function? The zeros occur where x has a value of -5, -1, which means my x-intercepts are -5, 0, and positive and -1, 0. Took the lazy man way out and put plus or minus there. And the y-intercept is 0, 1. So that's the answer to number 6. What is the maximum value of this function? Well, this function has an absolute max of 3. And it also has an absolute min of -3. But if we were having to state all the extrema, we'd also need to say there's also a relative max of 1. Okay. The intervals where the function is increasing, it increases from -2 to 0, and then again from 2 to 4. It decreases from -5 to 2, and then again from 0 to 2. And it has a constant interval from 4 to 5. Are we good?
Yeah.
All right. Did you notice that this function is not continuous? There was a jump discontinuity. Did you see that? There was a jump. It jumped from here to up here. And what is the x value right there where it jumped? The x value was 2. What is the rate of change over the interval from where x equals 5 to x equals negative 2? Let's see. X equals negative 5 to x equals negative 2. Down 3 over 3. What is negative 3 divided by 3? Negative 1. From negative 2 to 0. So let's look again. From negative 2 to 0. Up to 4 over 2. What is 4 divided by 2? Positive 2. I was just able to count it on the graph. Any questions about average rate of change over these intervals? Okay, and then the last two, they gave us a new graph, and I meant to tell y'all in class, but I didn't, but lots of people asked, that this was stopping here and here, not continuing. So the domain went from about 0 to about 13.5. If you said 13 or you said 14, that's fine. The range went from 3 to 8, or something really close to that, because they're not quite perfect. And then we have increasing from 0 to 2, and then again from 4 to 6.5. Decreasing from 6.5 to 9, and then again from 11 to 13.5. And a constant interval from 2 to 4, and then again from 9 to 11. Questions?
No, ma'am.
Okay.
Miss Willoughby,
Yeah.
for number 12 on part B, for the
Yes.
constant, could we put the, when the x is from 6 to 7?
Did it look like to you that top part was flat?
Yeah, I just
Okay,
didn't know.
that's fine. Yeah, yeah. On the test, it'll be really clear.
Okay.